Good morning. Today we are going to see problems on projectile motion. This is last lecture before your examination, and we will also go for revision in short. So, problems we are solving that is on projectile. So we have first a car starts from rest. The car travels along the circular path with radius 50 meter. So we have given r equal to 50 meter. So this is given data. V is given 0.2 t square. Determine magnitudes of car velocity and acceleration at t is equal to 3 seconds. So at t is equal to 3 seconds, V is equal to 0.2 into 3 square. And this will be 3 3s are 9, 2s are 1.8 meter per second. So this is first. Then it is given acceleration. Total acceleration we have to find. So we have first dv by dt, which is at. Be very careful. We have at dv by dt, which will be 0.4 t. At t is equal to 3 seconds, we have value of at is equal to 0.4 into 3. And at we have 1.2 meter per second. This is not a, this is at which is along velocity. This at along velocity. And an which is perpendicular to the velocity, and that is an equal to v square by rho. Now v is given 1.8 square divided by rho is 50. And therefore we have an is equal to 0.065 meter per second square. And therefore a is a root of at square plus an square, and we will get value of a root of 1.2 square plus 0.065 square. After these three problems, we will go revision of this. 1.36 meter per second square. So total acceleration at t is equal to 3 seconds is 1.36 meter per second square. Then we have given at given instant the speed of the train is 20 meter per second. So speed is given 20 meter per second. We do not know coordinate and anything. Then given acceleration making angle 30 degrees. So let us we have somewhere here acceleration which is making angle 30 degree with the velocity. Determine the rate of increase of speed and radius of curvature. So we know always the direction of velocity. This is always tangential direction. So this direction, this is always tangential. That is most important. So we have this will be tangential direction, and perpendicular to this we have always normal. So along this we have AT, and perpendicular to this we have AN. And now from this diagram you can see this. We can find value of AT equal to angle is with tangential with velocity, so it is cos. So we have 14 cos 30. And we have this 14 cos 30 is 12.12 meter per second square. Means this is a rate of change of speed. So AT, this is nothing but the rate of increase of speed. And then we have AN, that is equal to A sine 30. And that is 20 sine 30. And we have this value 10 meter per second square. And then we know we have An equal to V square by rho. And therefore rho is equal to V square by An. And V we have 20 square. Sorry, this is A is given 14. A is 14, 14 meter, V is 20. So this becomes 7. And therefore we have 20 square by 7. And we have this value of rho, that is radius of curvature is 57.14 meter. We have this will be 400 upon 7. And then this comes 20 square divided by 14 sine 30. So 40 sine 30 we have 7, and 20 square by 7, 57.14. This is a radius of curvature. And then we will be with one problem, conceptual again. A golf ball is stuck with a velocity 25 meter per second, making angle 30 degrees. So now we will draw the diagram. So we have given this velocity 25 meter per second, making angle 30 degrees. Determine the radius of curvature at initial point. So again, we have this will be tangential axis, perpendicular to this we have normal axis, and we have total acceleration in this is g. Now this angle is 30, this is 60, this is 30. So g makes 30 degree with normal. So we will get an is g cos 30, and at we have g sin 30. We have to find a radius of curvature. It is related with an. So we have an equal to g cos 30 is equal to v square by rho, and v is 25 square by rho. And from this we will get 25 square divided by g cos 30, and value we have 73.57 meters. This is rho at initial. Now at maximum height, when it will go, this is g, because we have motion under gravity, and in this total acceleration is g. Now when it will go to the highest point, then our vertical component becomes 0, and we have velocity only in horizontal direction, 25 cos 30, that is Vx. And Vy becomes 0 because we know at highest point Vy 0. Your value of Vx is constant throughout. Constant throughout. And so now V at highest point, V equal to Vx, and that is 25 cos 30. And now this becomes your tangential axis. So this is your tangential axis. Perpendicular to this, we have normal axis. So now An equal to G and At equal to 0. And therefore we have An is V square by rho. Now An is G, and therefore rho is equal to V square by An. V we have 25 cos 30 whole square divided by An is G. And from this we will get 25 cos 30 square divided by 9.81 is 47.78 meter. So your value of radius of curvature is always minimum at highest point, because at highest point velocity is minimum, which is Vx only. And as velocity is minimum and an is maximum at highest point, which is g, and therefore numerator is minimum and denominator is maximum at highest point, because we have formula rho v square by an, and at highest point v is minimum, which is Vx, and an maximum, which is G. And so numerator is minimum and denominator is maximum, and therefore rho becomes minimum. Now just revise it. So you have constant acceleration where you have to use three formulas. So here your acceleration should be constant. Be very careful with this. If accelerate, this is a constant. Then if a is variable, a equal to 5t square minus 6t, then this is variable. And then in this case, we have to go for derivatives or integration depending upon the given data. Then we have third, that is motion under gravity. And in this, we have three equations: v equal to u minus gt, v square u square minus 2gy, and y ut minus half gt square. And g we have 9.81 meter per second square. Upward we have positive, downward we have negative. And g already minus sign is taken, so it is 9.81 meter per second square. Then we have tangential and normal. In this, my equations becomes Vt equal to Ut plus At into T. Then Vt square equal to Ut square plus 2At into S. And S equal to Ut into T plus half At into T square. And then we have An equal to V square by rho. So velocity change is due to tangential acceleration only. Tangential acceleration. And An keeps body along curve. And this is also known as centripetal acceleration. And last we have projectile motion. And in projectile motion, we have Vx is constant, Vy changes. Therefore, we have x equal to Vx into t. And for y, we have to use equation of u t minus half gt square. Then Vy is equal to Uy minus Gt, and Vy square is equal to Uy square minus 2Gy. So this is your projectile motion. Now at maximum height, rho is minimum, An maximum, which is G, and V equal to V minimum, which is Vx, V cos theta. Theta is angle made with horizontal. And then actually we have, this is for your kinematics. For kinetics, you have, keep in mind impact. So we have one equation, m1u1 plus m2u2 is equal to m1v1 plus m2v2. And second equation, E is equal to minus v2 minus v1 upon u2 minus u1 minus u2. Exactly reverse, or you can write E is equal to v2 minus v1 upon u1 minus u2. First, that is plus sign. So this is very careful, students making this mistake. So if you will take both two first, then you have minus v2 minus v1 upon, then you have u2 minus u1. So if you have taken both before, means in both cases, if you have taken two before, then that is most important. You have to take with minus sign. Otherwise, v2 minus v1 upon u1 minus u2. This 2 here 1. If minus is taken outside, then you can take both 2 and 1. Then we have work energy principle. That is, force into displacement is equal to mv square minus mu square by 2. Then we have Newton's second law, F is equal to ma. So we have to use this properly, apply this and solve the problems. Keep in mind this E most important, 2, 1 and then 1, 2 with plus sign. And with minus sign, 2, 1, 2, 1. That you have to decide. So be very calm while solving the question paper. Don't be under tension. Write given data properly. Write coordinates of space forces properly. And then solve it. All the best for exam. Now we will stop here only. Thank you.